Okay, so this Excel help video tutorial, whatever you want to call it. I'm going to go in over t-test. Okay, so we'd use this when we're looking at for differences between measurements from different samples. Okay, so what does this test tell you? It tells you if there is a statistically significant difference between two means. Okay, and you can only do this when the sample size is less than 25 and the data is normally distributed. Now, what do I mean by normally distributed? I mean, is it a normally like a bell curve? Things like that. If you have no idea what I'm talking about, please view the other videos to help yourself get yourself acquainted. It will be under standard deviation. Okay, but on with this one. So here is a nasty equation. Alright. Give you just a few minutes just to stare at that, okay? Seems quite daunting. But in Excel, you can break down this, okay? Because I know in a scientific calculator you can get lost in the numbers so very, very easily. So by using Excel, you can set out clear intentions and do it part by part by part, okay? Which is what I'm going to be showing you an example of today, okay? Now, if you do create this spreadsheet on Excel, you can save it, you can use it in your own practical, you can use it on different sets of data. Of course, you will be able to use it in an exam, but getting used to that formula and used to doing it on Excel, for me, is more beneficial than trying to do it on paper, trying to do it in a calculator, because I've tried it before and you can get so lost in the calculation, and when you hand it in and it comes out back wrong, like try again, you're like I did everything. But on an Excel spreadsheet it will tell you if it's wrong or if you've inputted it wrong. It's just easier in my opinion. So here is a worked example. Okay, so I have a question. Does the pH of soil affect the seed germination of a specific plant species? So we have two sets of data. Both of them have 8 pots. Okay, so in total we have a sample size of 16. 8 of the pots have a pH of 5.5 and the other 8 have a pH of 7. 50 seeds were planted in each pot and the number that germinated in each pot was recorded. Okay, and this is the data right here. Okay, so this is Excel spreadsheet. As you can see, I've got group 1 and group 2. Okay, so pause the video here, and if you want to follow along, please do that. But what's the point in doing this? Okay, so we need a hypothesis. Basically, you need a null hypothesis. So H0, HO is the null hypothesis. This is the hypothesis that there is no statistically significant difference between the germination success of seeds in two soils of different pH. Okay, so that's a null hypothesis. There is no statistically significant difference between the pH. Okay, basically pH does not affect the germination. Very confusing wording. HA is the opposite of the null hypothesis, right? So there is a significant difference between the germination of seeds in the two soils at different pH. Bit of a tongue twister, isn't it? Okay. So basically it means, does pH affect germination of seeds, which is what we're going to calculate. Okay. So if the value of t exceeds the critical value, so probability of 0.05, that means when we make this, we are 95% confident that this is correct, basically. Okay, so p is equal to 0.05. If it exceeds the critical value, then you can reject the null hypothesis. You reject H0, HO, and you accept HA. So you accept that there is a significant difference. Right? So what we're trying to prove or disprove, basically, is HO, the null hypothesis. Right? So first thing that we need to do is work out the mean. Okay? Need to work out the mean of these two groups. And the way we do that is equals. Whenever we put equals in Excel, we are telling the Excel to do something. We are going to tell it to calculate something. Right? Now I'm going to put average. Average. Open the bracket. Click and hold and drag down to the bottom. Close the bracket, press enter. Yep. Do the same for the other group. Close, enter. There we go. Okay. Next, we're going to work out this. It's a bit what the hell is that, right? So basically, the mean is also known as x bar. Okay? Mean is also known as x bar. This is my abbreviation form, I guess you could say. So all this means is x minus x bar squared. X bar squared. Right? To help you. It's this bit here. This bit here that I'm on about. Right? So x is the value and x bar is the mean. So equals open bracket. I'm going to do x minus x bar. Okay, I'm going to close the bracket and do a hat. That is shift 6 to make that hat, and then 2. So what I'm telling it to do is I'm telling it to calculate what's in this bracket first, and then you're going to square it. Now, to make it easier for yourself, before the B of the 10 of the B10, put a dollar sign and put one there as well between the B and the 10. Now that means you are telling the spreadsheet to stay on this cell. Okay, so you're going to click enter. Well, press enter. Okay. Now, because you put these dollar signs in it, that last number, this number will not change. This one will. Oops. Yeah. Okay. Now, I'm going to do a trick. So here you see a little square. Little square within a square. Inception. Okay. It's going to turn the cross black. You're going to click and hold and drag. That's a quick way of doing it. Okay. So we're going to do the same on this side. We're going to open the bracket. X minus x bar. Close and square it. Again, you're going to do your dollar signs. Enter. You're going to click and drag. There we go. Now, to calculate standard deviation. To calculate standard deviation, we need to do this. What does that mean? That is the Greek symbol. The Greek symbol. God damn, where am I? There. Greek symbol sigma. Okay? And all Greek Greek letter sigma means is the sum of. So you add them all together. Okay? So I'm going to input that there. If you're trying to scroll through and you can't find it, use this character code. Okay, so it's 03A3. You paste that in there, you press insert, and it'll automatically insert it for you. Okay. Okay. So equals sum, open bracket, click and drag. So you're telling it to add all those numbers together. Same on this side. Tell it to add all those numbers together. Okay. Now, standard deviation. We need to work out the standard deviation for both of the groups. Oops. Standard deviation for both of the groups. We're going to do that. Is this. Okay. So it's equals SQRT. That means square root. Okay. Open the bracket. You're going to open the bracket again. You're going to click what we've just calculated. Divide n minus 1. So n is the number of groups, or pots, I guess you could say. So it's going to be 8 minus 1, which is 7. Yeah, make it easier for you. 7. I'm going to close the bracket and then close the bracket again. That's just to tell it that you want this calculating first before you square root it. Press enter. And do the same on the other side with the different numbers. Open the bracket again. 82 divided by 7. Close. Close. Enter. Okay. Is that right? So we've got 3.42, yes, and we've also got 2.36. Brilliant. Yep. Now comes the hard bit. That daunting equation that you saw first. This one. Okay. So let's make it easier on ourselves. Okay. I'm just gonna pop this here so you can still see the equation, yeah? Hopefully. There we go. No. Ah, there we go. Okay. So we're gonna break this equation down. Break it down, okay? It's going to have x bar 1 minus x bar 2. Okay, I'm also going to have s1, and that's squared, divided by n1, and s2 squared divided by n2. So I've done this and then these two before it's square rooted. Notice before it's square rooted. There we go. Okay, so equals that number minus that number. Yep. I'm going to open the bracket because I want to square the number first before dividing it. Okay. So that is this number squared divided by n, which is 8. Enter. Same again, but with this number. Would help to open the bracket. There we go. Divided by 8. Enter. Okay. So now we've got to square it. We've got to do this bit on the bottom. This bit. Got to do this bit now. Okay. So SQRT. Open the bracket. Open the bracket. Don't forget we need to add them both together before it square roots. That one. Add that one. Close the bracket. Close the bracket. Enter. Right. Just to make it clear. T-test. Okay, so the value. It's going to be top divided by the bottom. Okay. Of course, this says it's negative, but because it's t-test, you don't necessarily need to worry about it being negative. Okay, so it's 2.99, just a normal number, not the minus number. Okay. Now we need to compare it. Okay. Compare our calculated value of, that's supposed to say t, with the relevant critical value in the stats table. Sorry, I'm really tired. Okay, so our value of t is 2.99. Degrees of freedom, yeah, is n1 plus n2, which is 8 plus 8. 16 minus 2 is 14. So then when you look on the stats table, degrees of freedom is 14. Critical value is 0.05. No, critical value. Probability is 0.05. Sorry, tired. Critical value is 2.15. Okay. Our value of 4t exceeds the critical value. Okay. Remember, we're trying to figure out if the null hypothesis is correct, if we accept or reject it, right? So because t exceeds the critical value, we reject the null hypothesis. Meaning there is a significant difference between the two means. So pH does affect the germination rate for this particular plant, for this particular species. Okay. Here is another example. If you wish to try that out, okay, please pause the video here, change your values, and let's see what you get. So for this t-test, our t-value comes out at 1.12. Okay, it's the same degrees of freedom, so the value is still 2.145, a bit more accurate. Anyways. But because our critical value that you've calculated is less, because the t-value is less than the critical value, there is no significant difference between the yields. So you accept the null hypothesis in this case. Okay. The test can be made more reliable by increasing the number of data points. So instead of 8, increase it. And then maybe you may see a significant difference. Maybe, maybe not. Right. Another use of t-test is for matched pairs. Okay, matched pairs. This is used when two sets of data are linked in some way. And again, each set of data is normally distributed. Okay, so for this example, I'm going to be investigating whether the number of green fly on wild roses is related to the height of the rose. Okay, so green flies were counted on different heights of roses. Okay. So this is our data set. Okay, I'm just going to copy that over. So we've got 2.5 meters, that's the tallness, 0.8 meters. And this time we've got 12, and that's 12 pairs. Okay, so there's the number of green fly that was recorded. 19. Okay. Right. So in this example, for the matched pairs, right, we need to calculate the difference instead. So D in this instance stands for difference. What you're going to do is that number minus that number. Black cross, drag it across. There we go. Okay. Right. You're also going to need the sum of the difference. Got to get that symbol again. That one, sum, open bracket. Okay. By using sum, again, we're telling it to add all these numbers together. Okay. Now we need to work out d bar. So the mean, it's going to be the sum of them all divided by how many pairs there are. Good. Okay. You are also going to need to work out, you're also going to need to work out d minus d bar squared. Okay. So what you're going to do is you're going to press equals, open the bracket, d minus d bar. I'm going to put dollar signs in front of the B and in front of the 7. So we're telling that cell, we're telling the formula that it needs to stay on that cell. Okay? I'm going to square it. Shift 6 and 2. Enter. I'm going to drag it across, all the way across for all of them. Okay. Fifth step, you need to make this sum, calculate the sum of all those. Equals sum, select. If I'm going too fast, don't forget you can pause the video. Okay. Now finally, we're on this step, because they've missed a lot of steps, right? So for this step, you're going to calculate standard deviation. Equals SQRT, open bracket, open the bracket again. Because what's going to happen is you're going to take that number and divide it n minus 1. So we have 12 pairs, 12 minus 1 is 11. Close bracket, enter. Okay. Now you've got standard deviation, you need to calculate standard error. And it's just a simple calculation. All you're going to do is equals, select the standard deviation, you're going to divide it by the number of pairs. Press enter. Okay. And now we can calculate t. So you are going to need this number, and you're also going to need this number. So t-test equals, to do that all you're going to do is d bar divided by standard error. Enter. Okay. So now you need to look up the critical value. Okay. Don't forget your degrees of freedom. So your degrees of freedom is the number of pairs of data minus 1. So it's 12 minus 1, which is basically 11. Thanks for giving me a date, Excel. There we go. So your degrees of freedom is 11. Now what you'll find is you can actually go higher with this if you wanted to. So instead of P being equal to 0.05, you can have P as 0.01, okay, which is the highest that you can go. That means that you are 99% confident of your value, okay? So the critical value in that case is 3.106. Okay, so that is your critical value. Of course, our data, our T, exceeds this value enormously. Okay, there is a significant difference between the two. So because it exceeds, we can reject the null hypothesis that there is no significant difference. Just going to get it again. There we go. Okay. So remember, the null hypothesis is there is no statistically significant difference between determination between the number of green flies on a rose and its height. We've gone way over. So that means that height does correlate to the number of green flies. So the number of green flies increases as height increases. Alright. Thank you very much. I'll see you in the next one.